Continuing on with our 8.1 lesson, we're looking at example 2 here. In our first couple examples, they look something like this, where we took the equation and we factored it first and then found some solutions. And these ones, we are already given our equation in a factored form. And we're asked to find the x-intercepts and the y-intercepts of the graph that it makes. So in this case, for example 2, part A, this factored equation, y equals negative out front here, and then as a factor x minus 2 squared, this would give us this graph, this parabola right here. Now if this is kind of confusing or tricky to think of this as a factored form, I'm going to break this apart into 3 different pieces so you can see why it's actually a factored form. This negative is like we're saying negative 1 times all of this. And this squared piece right here, it actually means that there are 2 factors or 2 pieces, x minus 2 and another x minus 2. So it's 2 different parenthesis sets, this red one and this green one, being multiplied together. And when you multiply something times itself, that's like squaring it. So you can just say x minus 2 squared, because we have it here twice. And we have multiply everything by negative 1, which is why we have this like negative sign in front. So this is kind of maybe an easier factored form to look at. Now when we look at this one as a factored form and see how it relates to this graph, there'll be a couple of interesting points that we can look at here. And I want to go over our x and our y intercepts. Remember, the x-intercept is where y equals 0. So just by looking at our graph, we can see that that happens one spot, right here. What is the x value at that spot right there? 2. We'd say x is 2, or we'd say our x-intercept is 2. Now, how else can we figure that out, or what else lets us know that? Well, we could literally plug 0 in for y into this piece right here. Just like we did in our last examples over here, we had this whole thing set equal to 0, found the 2 different factors, and said, okay, how can I make this factor 0? How can I make this factor 0? Well, let's look at this. How would I make this factor 0? X would have to be 2. How can I make this factor 0? X would have to be 2. So in either case, x has to be 2, both times. That's why there's only the one x-intercept. Happens right there. I'm going to get rid of that little 0 there. So that's our x-intercept. You can find it just by looking at the graph and seeing where we cross through there, or you can literally set y equal to 0 and solve for what those factors would have to be. Y-intercept is the next piece we're looking for. Again, that means, oops, I'm going to do this first, it means where x equals 0, or on our graph, it's where it touches this y line. It happens right here at negative 4. Let me get rid of this. It happens at negative 4, or you can say y equals negative 4. Well, what would happen if we actually plugged in 0 everywhere we see an x? So like right here and right here. 0 minus 2 is negative 2. 0 minus 2 is another negative 2. And we have a negative 1 out here. So it's saying negative 1 times negative 2 times negative 2 equals y. Negative 1 times negative 2 is positive 2. Positive 2 times negative 2 is negative 4. Right here. Y equals negative 4. And we can see that, or it shows up right there on our graph. So that's why, or how, we can find our y-intercept, again, either looking right at the graph or going back to our equation up here and plugging in 0 for x. Plug it in 0, solve it out, whatever y is, that's your y-intercept. Same thing with your y, plug it in as 0, use your factors and set them equal to 0, find out what your x's would have to be. So let's do another kind of similar one. Example 2, part B. Same thing, we need our x and our y-intercepts from each graph. In this case, again, it's given to us as a factored form. We have an x plus 3 and an x plus 7. Now, they also have this extra coefficient, but that third thing won't necessarily matter. Because again, all we're trying to do is set these equal to 0. So once one of them equals 0, you can multiply it by as many different things as you want. It'll still be 0. You can do 5 times 7 times 100 times 1 billion times 1 trillion times 0, and it'll be 0. You just need 1 times 0 in there to make it 0. So we have our factored form, just like we did in our last case. Remember, x-intercept means where y equals 0. We find that right here. So we can say, all right, we know that that means our x or our y-intercept. Oops, I'm going the wrong way. If I want y equal to 0, my bad. I was on the y-axis. If I want y equal to 0, that happens here and here. So that's the -7 and the -3. And again, that means that I plugged in 0 for y and found my two factors. X has to be a -3 to make this 0. X has to be -7 to make this 0. That's why it's the two spots where it hits the line there, if we just simply set y equal to 0. Get these out of the way. So those are our two spots, x equals -7, x equals -3. Just take those out. The y-intercept, that's the one I was working on before, again, is just the spot where we hit the y-axis. Now, that means that our x value is going to be 0. So again, we could literally just plug x equals 0 into here. Or if we look on our graph, we'd find, oh, that happens right here at 7. So we know it's going to be 7, but let's double check just to be sure. We've got that number 1/3 times, we're going to plug in 0 right here. 0 plus 3 is 3. We're going to plug in 0 for this factor. 0 plus 7 is 7. So we've got those things being multiplied. 1/3 times 3 times 7. Well, 1/3 times 3 is 1. A third of 3 is going to be 1. 1 times 7 equals 7. So that's why it turned out to be y equals 7. Again, you can see it on the graph, or you can literally plug in x equals 0 and figure it out that way. Without graphing, find the x and y intercepts. Well, again, good thing we figured out how to do that. Y-intercept is going to be where x equals 0. So we're literally just going to plug in x equals 0 into these cases. If x was 0 right here, we'd have -0 times, if x was 0 right here, 0 minus 3 is going to be -3. So -0 times -3. Well, you can't really have a -0. It's the same thing as a regular 0, but 0 times -3 is just going to be 0. So our y-intercept is right there at 0, so we'd say y equals 0. So that's how to find our y-intercept. If we want to find our x-intercept, again, that means it's where y equals 0. How do we solve for that, or how do we find that? We take this f of x, which is the same as y, set it equal to 0. So we'd have 0 equals our two factors. Whoops, I'm going to do one in red. Do -x, and the other factor in blue, x minus 3. Okay, so I literally just plugged in y equals 0 for that piece, and we'll see what we get. How do I make this factor 0, the red one? Well, that's 0. How do I make the blue factor 0? What minus 3 would be 0? That would be 3. So these would be my two x-intercepts. We'd have x equals 0 and x equals 3. Even though it said without graphing, if I needed to, I could now graph this out, and I would know that I touch this x-axis here at 0 and at 1, 2, 3, and I touch this y-axis right here at 0. So although I don't know everything else, I don't know necessarily how the parabola looks, I know that I touch these 2 points on the graph. So that is kind of a nice helpful piece of information there. Let's look at example 4 then. Without graphing again, find the x and y intercepts. Now this one isn't as kind to us. In the last one it was given in factored form. This one we have to factor first. That shouldn't be too big of an issue. If we have a trinomial given like this, remember we can just kind of pretend that we've got 1 out here, and we do 1 times 5 is 5. And we'd start with our factors of 5, the only possible ones being 1 and 5. If we want our factors to add up to -6, that means both of these have to be negative, -1 and -5. So now we can break it apart and say instead of y equals this trinomial, y is going to equal this 4-term piece. We broke -6x into -1x and -5x. Where did we get those from? Right here, -1, and here, -5. Now we can do factor by grouping. We'll group this piece and we'll group this piece. So that'll become, take the x out of these ones, x comes outside and we're left with x minus 1. Take the -5 out of this one and we're left with x minus 1 here and -5 on the outside. So now in factored form it would say y equals x minus 1. Again, remember that's this part. The x minus 1 that happened in both pieces is right here. And x minus 5. And that was this -5 and this x right here. That's where our factored pieces come from. Now that we have the factored form of our equation, or of this quadratic function, remember the y-intercept is wherever x equals 0. So if we were to plug in x equals 0, we would get 0 minus 1 is -1 times 0 minus 5 is -5. -1 times -5 is +5. So that would be our y-intercept. I'm going to get rid of that. Our x-intercept is wherever y equals 0. So instead of y, we can literally just plug in a 0 right here, get rid of that stuff. If this is 0, and we've got two factors, that means we either want the red piece to be 0 or the blue piece to be 0. How would this red piece be 0? Well, x would have to be 1. How would the blue piece be 0? X would have to be 5. So our two possible factors or solutions there are 1 and 5, or I guess you could say x equals 1, x equals 5. With all that given information, even though they don't necessarily ask, we can graph exactly what this will look like. X equals 1 right here. X equals 1, 2, 3, 4, 5. I'm going to say somewhere out here. Those are x-intercepts. And we have a y-intercept at 5. 1, 2, 3, 4, 5. So our parabola would look something like this. We can figure that out without having to make a table and plotting our points. It has to go through these 3 points for sure. So it should look something similar to this parabola. And that'll cover our first section for quadratics.